Hello, Algerians and all cloud native enthusiasts out there. As summer almost behind us, it's a great time to dive into new learning opportunities, maybe meeting new connections, and making the community a better place to operate in. My name is Youssef, and I am a DevOps engineer at Gimlet. Well, simply put, I enjoy being around clusters, just like you do. I have been jumping around cloud native events like KubeCons, meetups, and KCDs. And I always wanted to meet fellow Algerians, but there was no clear path on how to do so. So I thought, why not having a community that brings us together? Yeah, that's it. And here we are at the first webinar of Cloud Native Algeria. Cool, no? Alright, since it is the very beginning of Cloud Native Algeria, and in case you want to help the community become better, I have set up a GitHub repo that has all the information on how to join. It also has a Discord link so we can have chats there. Moreover, there is a bi-weekly meeting on Thursdays where we will discuss the current state and what we should do next. Well, today, Daniel will be joining us as the speaker for our first webinar. He will introduce you to the cloud native ecosystem, share some current industry insights, and wrap up with the basics of containers and Kubernetes. He will also provide a guide for those looking to get started with cloud native technologies. And now, sit back and enjoy the webinar.
Thanks for having me. I just wonder, it's actually quite funny that we have two CNA communities right here, so Cloud Native Algeria and Cloud Native Austria. Yeah. Maybe just to kick things off. So today we're going to talk, or mainly I'm going to talk about Cloud Native and Kubernetes. Going to give you a little technical introduction, so that's not going to be one of those deep dive technical hardcore talks, but more just to give you a little teaser of what Kubernetes actually is, what Cloud Native means, how this technology stacks works, what's the difference to like the traditional approach. And I'm also going to give you some kind of introduction to some key figures, some key numbers of the industry, and especially how to get started with Cloud Native as a person, but also as an organization or as a company. If you have any questions, please just drop them in the chat so far, and we can definitely discuss in the after the talk. So I'm also happy to stay. I have no plans for today anymore. So just feel free to leave your questions in the chat, and we can talk them through afterwards. So as Youssef already said, my name is Daniel. I'm also a DevOps engineer. I'm working at Fullstacks, which is an Austrian-based company. Besides that, I'm also like kind of a community organizer. I'm the host of the Cloud Native community in Graz, which is the second biggest city in Austria. I'm also one of the initial hosts and organizers of KCD Austria, where the two of us actually met last year. So if you're in Austria by any chance in October, feel free to come by. 8th to 10th of October, we're going to have the KCD Austria again, Kubernetes Community Days. As for my education, I studied some things and I did quite some certifications in the past some years. If you want to reach out to me afterwards, just feel free to drop me an email or text me on LinkedIn or whatever. You'll see my contact details at the end of the slides again. All right, so today we're going to talk about, in the first place, what is Cloud Native? What does this term mean in a broader sense? I'm going to introduce you a little bit to the Cloud Native ecosystem. We're going to have a little technical introduction about what actually containers are, what Kubernetes is, some Kubernetes basics, and how containers and Kubernetes especially contribute to this idea of having things cloud native. Spoiler alert, containers and Kubernetes are not the only technology out there that is cloud native, but it's kind of the flagship there. And towards the end of the talk, I'm going to give you some best practices on how to get started on a personal level and also on an organizational level. If you're up for the discussion, we can also talk on how, or maybe give you some best practices on how to get started as a community, since in Austria, or at least in Graz, we're doing this for about 3 years now. We also have regular meetings. So just as you proposed, we usually have them like once every 4 weeks in person. And then we have our kind of flagship event once a year, the Kubernetes Community Days. So yeah, we're somewhat successful in keeping up the community spirit here in Austria as well. And I hope you also do a nice job, and I'm perfectly sure you will do also in Algeria. Okay, so don't be scared. Wall of text. What is cloud native and what does it mean? The wall of text you see here is basically the definition provided by the CNCF, which is the association that is basically governing this whole cloud native ecosystem nowadays. And this pretty much says that cloud native technologies empower organizations to build and run scalable applications. So it's definitely focused on the application in a modern dynamic environment. So we're not talking about static environments, on-premise environments we used to have in the past. We're now talking about dynamic, ever-changing, fast-changing, elastic environments, such as public, private, and hybrid clouds. At the end of the day, a cloud is nothing else but an automated IT infrastructure maintained by somebody else usually. But the key information here is automation, application focused, and dynamic. So this usually contains containers, service meshes, microservices, immutable infrastructure, declarative APIs, and such as the technological buzzwords, if you will. The important part here that these techniques enable kind of loosely coupled systems that are resilient, manageable, and observable. So you not only have these kind of smaller sized applications thrown into some cloud, you want to have them loosely coupled. You want to have them resilient, so kind of error prone, manageable also, especially if you want to like manage thousands of microservices, you still need to have them manageable. Not like the one holy server you used to have in your basement, but you want to have thousands and hundreds of small applications, but still being able to manage and observe them. Of course, robust automation is a kind of the centerpiece to make this happen. And one of the kind of new paradigms, if you will, is the possibility to make high impact, frequent changes that are predictable with minimal toil. So you actually want to update these microservices or these pieces of software on a quite high frequent base, but you also want to have a kind of predictable outcome. Like in the past, we had these big enterprise software updates once a year when nobody was perfectly sure if the system will work afterwards. The paradigm nowadays is to have smaller pieces of code, higher frequency of changes, smaller changes, and more predictive changes. So to sum it up, cloud native has no like one word definition. It's more like a paradigm of doing things compared to the traditional way of application development and infrastructure, if you will. And it's more focused on automation, dynamic environments, smaller but more loosely coupled applications and microservices, which is kind of the buzzword. And we actually try to find technologies that empower us to leverage such systems and build such applications. So kind of the container is not the reason for cloud native. It's more like a solution to implement the paradigm of cloud native. I think the term cloud native actually stems from being able to deploy newly built applications natively on such cloud environments. As I said, cloud just means automated infrastructure providing an API at the end of the day. Okay, this usually looks from an application perspective something like this. Somewhere you almost always have some kind of a virtualization platform, since we want to build smaller pieces of code, microservices, small applications, and you don't want to kind of waste a whole bare metal server, and you also want to have the benefit of automation. You kind of want to have some kind of virtualization platform in place. However this may look like. So this doesn't have to be Kubernetes, it could also be something else. Now, Gregor Hoppe, which is one of the most famous IT architects nowadays, described cloud applications with this FROST acronym, which starts with the first word, which is called frugal, which means it's kind of small, self-contained, efficient, in a sense that applications, as I mentioned, tend to be smaller than they used to be. If you think back, like, I don't know, 15 years, 10 years, 15 years, we had this huge Java enterprise server-based applications that were all deployed to one big server infrastructure that only scaled vertically. So you had to put in more hardware resources to get more performance and more features. Nowadays, we tend to split these monoliths up into microservices to smaller applications, which are frugal and which are deployed one by one on some kind of virtualization platform. That's what we see here. CT just stands for container. The next thing that we want to have in a cloud native ecosystem is we want to have applications relocatable. We want to be able to deploy them on our data centers, on premise, on my notebook, but also on the cloud, on Microsoft Azure, on AWS, on Google Cloud, or on some local cloud, for example, if you have a local cloud provider. So one of these paradigms is not to only have smaller and easier manageable applications, but also relocatable applications. And this is especially where Kubernetes will come into place as a some kind of standardized platform layer, if you will. So the next thing is we also want to be able to observe our data better than we used to do. Like in the old days, the things we tried to monitor, if you will, is something like file system size, if your file system is already running full, CPU, memory, disk size, and that's pretty much what we used to do back in the day. Now we actually want to have more and deeper insights in the application itself. So we're not that much focused on the infrastructure, still are, but the key idea that we want to focus on is actually the application itself. And there nowadays we kind of figured out that there are 3 to 4 like key telemetric signals, if you will, which are traces, metrics, and logs. So observability is also one of the big cornerstones of cloud native and cloud native applications. Since now we have these many microservices, but you still need to know what's going on between these microservices with one another of these microservices. So you need to be able to still figure out if everything is okay. The next thing that's kind of a paradigm, according to Hopke, is the possibility to seamlessly update containers. So this usually happens in some kind that you deploy a newer version of an application while the old version is still running, the new version takes over, the old version is being shut down. No interruptions, zero downtime, seamlessly updatable from a technical point of view, but also from an application internal point of view in terms of data migrations, only small changes, as I mentioned before. So if you consider an application cloud native, you also want to be able to update it seamlessly from an infrastructure point of view, but also from an application point of view. The next thing that's going to be one of the key paradigm shifts that we see is that cloud native applications tend to be secured internally. So the idea in the old days was that you pretty much have like this one enterprise Java server where you have all your services running and you secure the server. You have a web application firewall or a normal firewall, something like that, in front of this server. But pretty much the infrastructure is responsible for securing the application. Nowadays, the paradigm and the idea is to have each and every one of these microservices secured from the inside out as good as possible so that you don't have to rely on external security features anymore. Since we're going to see in about half an hour or something like that, that containers at the end of the day are just small mini operating systems, if you will. You want to harden them, you want to secure them, you want to make sure that the application is pretty much self-secured without having to rely on the outside world too much. And the last thing is we want to be able to have a failure tolerant system. So like in that example here, we see that if for whatever reason a container would stop, we usually want to have the platform to restart this application to not have any downtimes. Back in the old days when my server went down, most of the times it was down. In new cloud native ecosystems, we are talking about these microservices, and once a microservice goes down, the platform is responsible for keeping up the service availability and starting a new container right away, or having multiple container running in parallel and doing some kind of routing and resilience, improving kind of load balancing, if you will, to make sure that your application is always up and running and is failure tolerant. And even if something should go south, the application will still recover from a shutdown or from some kind of failure. So that's pretty much another take on the paradigm provided by Gregor Hopke, which tries to explain how cloud native applications look like and what this paradigm actually means. So to recap, we talk about smaller sized applications, usually referred to as microservices, usually implemented in some kind of container technology, not exclusively, but that's where we are right now, hosted on some kind of virtualization platform. And these applications should be observable, relocatable, internally secured, and as failure tolerant as possible. If it was too fast, just don't worry. We're gonna have another look at that in some slides. Okay, from an infrastructure point of view, this will look something like this, and the kind of contradiction here is that since we always try to strive forward and become better in what we do, and it's somewhat agreed upon that cloud native is better, if you will, than the old traditional way of static infrastructure and applications, the stack needed to actually implement and run such a cloud native ecosystem is way more complicated than we used to have before the cloud native era. So as I said before, we usually had this kind of Java enterprise servers or .NET runtime, stuff like that. But that's pretty much it. We had to maintain the server, deploy our ER files, application is running, everything's fine. Nowadays, to actually deploy some kind of application to a cloud native platform, there is so much infrastructure that you need to maintain, that you need to consider, that you need to have a look at, that you need to actually keep patched and up to date. And the stack usually will look something like this. At the base, we have some kind of infrastructure as code, where we actually provide the infrastructure, the nodes, the networking, the storage, etc., to create a cluster or a platform in the first place. Since we automate everything, we also have infrastructure definitions as code. So we usually don't click our servers in the cloud anymore, but we try to configure and provide and provision them as code via tools like Terraform, Crossplane, something like that. When we're done with that, we usually have some kind of a cloud native platform, a container orchestration platform in place. This could be, for example, Kubernetes, but could also be something else. Once that is in place, we actually need to consider how we actually deploy our application to such platform. So for that, we tend to need some kind of app delivery system, pipelining, CI, CD, build systems all around that area. Once the thing is actually deployed, as I mentioned before, we want to observe it. So we actually, again, need another tool for that, for observability, for security. Things, for example, like Falco, Trivi, Prometheus, Jaeger, which are all projects in the security and observability ecosystem. And then you actually also need to provide additional infrastructure services to your application. For example, persistent storage, if you want to store data, I don't know, load balancing, security scanning, certificate handling, stuff like that. So you also need infrastructure services provided on top so that your application can actually run as intended. And what we can see here is that we have multiple layers that we need to take care of before we can actually deploy and run one cloud native application. Once we're done with that, scaling and automation is going to be a big relief for all the applications that we're going to run in the future. So if your intention is to actually scale big time with your application landscape, cloud native is definitely the right place to go. If you're just for example, running or hosting one website and you don't expect millions of users, you should consider choosing a simpler stack, since you also need to maintain all these different layers of infrastructure at the end. But this is pretty much how such an infrastructure would look like in a nutshell. All right, let's take a step back from the definition and how the infrastructure levels look like, and focus a little bit on the ecosystem from multiple perspectives around this whole cloud native thingy. So before we do that, let's dive into some numbers. The CNCF, as I mentioned before, the Cloud Native Computing Foundation, the governing association of cloud native, if you will, conducts a survey each year where they ask companies about the adoption of cloud native technologies of certain projects and products. And what we can see here is actually quite impressive, that about 76% of all asked companies are actually using cloud native technologies in production already, and in other stages as well. And 66% are totally implementing cloud native exclusively. This means that cloud native has come to stay. Cloud native is not just a trend that will go away in a year or two, but this is a kind of a technology paradigm that is built to last. This will stay with us for the next years or decades, probably even. And we also see that the majority of companies is not implementing cloud native. So pretty much everybody is either playing around or already full out using cloud native technologies, but there's only a small amount of company that has nothing to do with cloud native technologies at all. And this is not only true for like tech companies or programming companies or IT firms, but this is also true for other sectors, for finance, for for producing companies, for automotive, for example, healthcare, you name it. Cloud native technologies are everywhere. The second thing I want to show here are the numbers regarding members of the Cloud Native Computing Foundation. Members, I'm going to talk about that in a second, are actually companies, so not persons, but companies, and end users as well. And we also see the contributor growth to Cloud Native Computing Foundation projects. For example, Kubernetes is also a CNCF project. And what we can see here is that since 2016, like in 2015, this whole topic or this whole trend started. About 7 years later, we have close to 250,000 contributors, active contributors to CNCF projects. We have close to 850, 900 companies being members of the CNCF or end users of the CNCF, which is close to like 1,000 companies publicly stating that they are active members of the open source community and are making active use of cloud native technologies, which is amazing, which is huge. And this is all over the world. So this is not just an American or European phenomenon, but this is actually companies from all over the world. I hope so. I hope so. All right. Now, if you talk about cloud native and the CNCF in particular, we need to talk about like 3 groups of stakeholders. We have the vendors that actually produce software products. We have the users that use them. And a big chunk is also projects and the community, such as we are. If you talk about the vendors, which are also the CNCF members, we can see that some of the largest companies in the world are CNCF members. So of course we have the big players like Amazon, Apple, Cisco, for example. But as I said, we also have companies from Asia, for example. We have Ant Financial, which is kind of the PayPal equivalent from China. And we have companies from different, at least IT sectors, being members. Also, for example, EY, which is one of the biggest financial consulting firms in the world. T-Mobile, which is the biggest German telecommunication provider. So as I said, different companies of different sizes all around the world contributing to cloud native and to open source communities in this ecosystem. On the other hand, we have end users. End users are also companies that publicly state that they are supporting the CNCF and they are working with these technologies, but they are not actively developing these companies. So that's the big difference. And here, for example, we have companies like Blizzard, one of the biggest computer games manufacturers, Adobe, the Citibank, MasterCard, Under Armour, like a apparel manufacturing company. So we have different companies from different industries. What you see here, that's actually the cloud native landscape. I also have the link of the landscape in the further reading slides at the end. The cloud native landscape is actually, it's a very good try to bring all these different companies, projects especially, together to one website and to give people an overview of what's actually out there. The CNCF is managing like hundreds of open source projects by now, and to still have some kind of an overview, the CNCF is managing this landscape to give you an idea of which projects are out there, how mature they are, which companies are out there, if they are supporting the CNCF and to which degree, to just give you an overview of all these entities out there. So you can see it here that we have projects, we have members, we have, for example, certified partners and providers to find training partners and training providers in your area. So that's a service provided by the CNCF to give you an overview of what's out there in the cloud native world. And then there we have the kind of the most important project and the project that started it all off, Kubernetes. Back in like 2014, 2015, 2013 maybe, there used to be Docker, which was kind of the first company that actually made the container technology publicly available and easily usable. So that's pretty much, the technology is quite old. So the technological basis for containers is quite old, but Docker Incorporated made it usable to the average developer. And like 2 or 3 years later, maximum, Google open sourced Kubernetes, which is kind of a layer on top to orchestrate containers on different nodes. And since then, Kubernetes got one of the fastest growing open source projects in the world, and was also the kickoff event to found the Cloud Native Computing Foundation. So Kubernetes was also the first project that was donated to the CNCF. And since it became so popular and the community wanted to keep this, this centerpiece of open source software kind of vendor agnostic, the CNCF was found to govern open source project maintenance and development, if you will. So Kubernetes is not managed by Google anymore exclusively, but by the Cloud Native Computing Foundation. Of course, Google is also a big player in the CNCF, but the CNCF ensures that no vendor has power over a certain project. Here we can see some numbers regarding Kubernetes. They're already like, I think, half a year old or something like that. We have about 75,000 contributors to this one project, over 300,000 code commits, 3.5 million contributions, over 7,000 contributing companies worldwide, about 100,000 GitHub stars, which is actually amazing. 40,000 forks. So it's actually, it's a huge project. One of the biggest open source projects out there, comparable to like Node.js, Visual Studio Code, or Linux. What I mentioned before, this task of governing projects is actually like the biggest concern of the CNCF, and they try to help projects cross this chasm. There used to be a book that's called Crossing the Chasm by Geoffrey Moore, which is quite famous in the whole marketing ecosystem and academic literature. And it pretty much says that if you bring a new product or project to the market, you always have this like 4 to 5 groups. you always have innovators, techies, and early adopters that want to try everything, and that will always try out your new product, that will buy it, but that's just a small percentage of the whole market. Then you have this chasm, and only then you have the majority part of the market. And most projects always have the problem that they're not mature and renowned enough to cross this chasm of pretty much market capitalization at the end of the day, to reach the majority of users. But they're never able to cross this chasm. And the CNCF is actually helping and supporting projects to be successful and to cross the chasm from this early stage development adopters to being used by the majority of users and companies. That's what they do. And that's also like one of the biggest criteria when a project governed by the CNCF wants to ascend in kind of the maturity ranks. They need to have some kind of overall adoption in the market, in the industry, for being promoted to a graduated project. So that's pretty much one of the biggest concern of the CNCF, to help projects grow, being adopted, and also being kind of professionalized. What we see here is a quite nice overview about some of the more famous and well-known open source projects out there. We have a logarithmic scale of commits and issues and pull requests, and we can see that Kubernetes is actually quite playing in the league of the big open source companies. So way more commits, for example, than Visual Studio Code or Terraform. Not so many as React, since React is also quite trending. But it's not that far also from Linux, from Chromium, from .NET. So we see that this whole ecosystem formed around Kubernetes and Kubernetes-based technologies is growing so fast. This slide is from 2019, so it's actually quite old already. By now, I'm pretty sure that Kubernetes is going even further to the right for being one of the most high-velocity open source projects out there. Here we have an overview of some of the graduate products. Maybe you know some of those names already. The interesting part here is that also if you can't identify any of these projects right now, let me tell you that the projects mentioned here is actually kind of a cross-section of the infrastructure stack I tried to introduce you in the beginning too. So for example, we have Argo in the top left, which is a deployment tool. We have Containerd, which is actually used to run containers in the first place. We have Core DNS, which is a small DNS server deployed in a cluster to provide local DNS. We have, for example, FluentD, which is a log collector and metrics collector. We have etcd, which is a distributed key value store and data store. We have Jaeger, which is used to collect and view traces. Of course, Kubernetes, which is kind of this virtualization platform that we've seen before in the square I had before. We have Helm, which is a package manager for this whole system. So what you can see here is we have different projects for certain areas of this whole cloud native ecosystem, and for the problems that you will hit sooner or later, there are many solutions available already. All right, let's switch firmly from the technical and the CNCF part a little bit back to the community part. As I said before, we need to focus on these three entities: the vendors, the projects, the members, and the community. Let me just briefly introduce you to the community we have in Austria and how we did so far. Now, if you don't know Austria, that's like in the center of Europe here. And this is where I live, where I'm currently talking from. That's Graz. This is the second biggest city in Austria. Vienna is over there. Graz is pretty much in the south of Austria. We have 350,000 people living here in Graz. And yeah, we have a cloud native community chapter there for about 3 years now. By now, we are one of 4 chapters in Austria. So in Austria, we have Linz, which is the third biggest city, Vienna, and I'm somewhat certain you have also heard of Salzburg. And we started off as different chapters, all of us doing our own little thing. And about 2 years ago, we decided that we want to have like this one unified community across all of Austria. So we pretty much took the different approach than you guys are doing. We then founded Cloud Native Austria, which is actually a legal entity, so that we also have the legal and financial means to support our communities across Austria and to also host KCDs or Kubernetes Community Days, since this is an event with about 300 to 400 people joining, which is kind of a financial risk, if you will. And for that, you want to have like an association or a legal entity. Yeah, so that's what we did like 2 years ago. Today we're having in October, we're having our second KCD event with about 400 people joining this year. We also have regular meetups in Graz, Linz, Vienna, and Salzburg, about once a month or every 2 months. Since COVID, we also stick to having them in person, so we don't do any virtual events usually. We try to meet people in person, since the personal connection is just way better, and the exchange of ideas and also the fun part is way better if you can meet in person. Yeah, so that's what we do here in Austria. Yeah, and if you're interested to also do some kind of KCD event in Algeria, you will find all the necessary information, of course, on the CNCF website. And at the end of the day, there's a Git repository, a GitHub repository, as we have for pretty much everything nowadays. Also, events are managed on GitHub. So if you want to host a KCD event, feel free to open a GitHub issue, and they will take care of you. All right, just a few more words about the KCDs internationally. So now, I think this year we had like 32 KCDs in person, virtual or hybrid, all over the world. So we pretty much have KCDs, except Antarctica, I think pretty much in each continent even. We had over 10,000 attendees, which is huge. As far as I know, the biggest community event we had was in Paris last year. They had about 1,000 or 1,200 people. And that's why they actually decided to also have KubeCon in Paris this year, because they did such an amazing job there and have a community event organized by community members for over 1,000 people. Yeah, we also have presentations in multiple languages. So as KCDs are, as I mentioned, community events, somewhat focused on the local community. It's also perfectly legit to have the talks and the whole event in at least also in your local language and also in English, of course. But we also have presentations, for example, in German at our events. Yeah, and of course, diversity is also like a big issue with the CNCF and with the KCDs. Okay, that's it with regards to the community. Let me just give you a very, very short introduction of what a container actually is, since this is the most basic technological building block to actually build cloud native infrastructure. And yeah, okay, sure, perfect, no problem. Okay, so containers 101. Back in the day, the first thing we had was this kind of bare metal server approach, where you basically just have bare metal, you have your server, you install an operating system on there, then you install your binaries, your libraries, the compiled code, and the application on top. Like this one thing, binaries, shared libraries on the same system, you're definitely going to run into problems there. That's why we came up with the idea of virtualization, which kind of works something like this, that you still have your bare metal server that you will always need. But then you have some kind of super slim mini operating system, if you will, that is called the hypervisor, that will actually abstract the physical hardware into virtual hardware. where you can install a virtual machine. So you have some kind of a virtual representation of hardware that you can then again install an operating system on. This is actually great for multi-tenancy, and it's also great for having, for example, different versions of applications running in parallel on dedicated operating systems, but still sharing the same hardware. That's how we used to do it until like 2010, 2015, something like that. But we still have this single stack of application, binary, operating system, and the virtual machine in one thing. This is what we usually call hardware virtualization. And then the next step that we actually have in kind of virtualization evolution, if you will, is container technology, where we still have like the hardware server, of course. Then we have an operating system. Could be in a VM, could also be on bare metal, doesn't matter in the end. And then we have some kind of software, piece of software called a container engine. And this container engine actually emulates an operating system. That's why we call this OS virtualization, where we can then run multiple applications separated from each other in little containers. That's why it's called a container, on the same OS, but they won't see each other and won't be able to interfere with each other. So the big difference is we don't need a VM and a dedicated operating system for each application. But what we do is we share the operating system, which is way faster, not that secure to be frank, but way faster, and it scales way better. The important thing to note here is container are inherently a Linux feature and a Linux technology. There are some adaptations to Windows, but that's not working properly. So we're pretty much always talking about Linux containers here. That's the important part. All right. If you have a look on this last piece, let me just briefly introduce you to how this life cycle and this whole workflow of building, running, operating, distributing containers and container images works. An image is pretty much just the file of that you want to distribute to a machine where you can then run a container. If you're familiar with programming, think of classes and objects. An image is a class and an object is one instance of this class. That's the same idea with containers and images. So for example, if we have like a Python image that can run Python scripts, we can start several containers from one script. So the image is pretty much just the distributable file, and the container is the running instance of that file. A container can, or an image can contain pretty much anything, since technically it's pretty much just a file system snapshot with some additional metadata. So what you actually do is you want to kind of Docker build, that's the command for that, build an image where you specify which components you want to have in that image, create some kind of a desired state of a file system, and then you take a snapshot of that. And once you start that container, you just run one process in this snapshot of the file system. Technically speaking, this works something like this. We have a client which has some kind of a client tool, which, for example, could be Docker, but could also be something else. Docker is just the most widely used, also still nowadays, since they were the first one. We then actually have the Docker host, where we have the daemon, which is the runtime or the engine that we've seen here before. So this would be Docker. And when we try to run a containerized application and we say, okay, Docker run, for example, run a Redis application, the client would actually talk to the daemon, to the container engine or container runtime. The container runtime would then pull the image from a registry. A registry is pretty much just the same as any package registry that you're perfectly familiar with, like an npm or a PyP or a NuGet registry at the end of the day. But instead of having npm packages, we have container images. The daemon would pull the image and would then start a container from that image. And the cool thing is that if I want to run another and another and another container from the same image. I just need to pull it once, and I can start multiple instances from this single image. And the next cool thing is that images are actually composed of multiple layers. That's how we call it. And if images share different layers, I don't need to download each and every layer every time. I can just reuse the layers that I already downloaded to my local machine, which minimizes network traffic by a lot. So this is pretty much just how this whole thingy works at the end of the day. We have a client that is giving instructions to a container engine or container runtime. We have a registry that stores the files, the images, that can then actually be started by the container runtime. And these containers will be little separated environments sharing the same operating system, but not seeing each other. So they cannot interfere on a file system level, for example, or on a process level. They're still isolated. Okay. That's all you need to know about containers, basically. And the big add-on that we now have is, and that's what you see here, we're still talking about single host. So containers is like a one single host technology. To make containers available across multiple nodes, we need an orchestrator software, and the most popular one is called Kubernetes. K8 is just an abbreviation for Kubernetes. Okay, so Kubernetes is actually like an open source platform for automating, deploying, scaling operations of application containers across clusters of hosts. That's what ChatGPT says. The big buzzwords you need to consider when you think about Kubernetes is it's a cluster. So you usually have 2 or more or 3 or more nodes in one cluster. You can also have single node Kubernetes, but that's somewhat out of the ordinary. Everything is API driven. Again, as we've heard before, cloud native is heavily focused on automation. We need APIs for that. And the heart and soul of Kubernetes is just a very strong API. We do everything as code. So Kubernetes works pretty much as code exclusively. And as I said, it's all about automation. Kubernetes looks something like this from a high-level technical perspective. On the left-hand side, we have a user interface or a command line tool called kubectl. Again, pretty similar to Docker. This is the client side. Everything a user does at the end of the day always lands at an API server. API server is part of the control plane or of the master node. And each cluster consists of a master or control plane node, one or many, and of several worker nodes. These nodes are responsible for the management of the cluster, and the worker nodes are responsible for actually running containers. That's what we see here. So on the left-hand side, we have actually 4 components comprising this control node. We have the API server, which is the single source of contact in all of the cluster, from the inside and from the outside. We have the scheduler, which is responsible for scheduling containers to certain workers. We have the controller manager, which is actually responsible for handling all the internal ongoings of Kubernetes. And we have etcd, which is the database or the state store, if you will. And on the other hand, we actually have the workers, which are solely there to run containers. In Kubernetes, we talk about pods. One pod could contain of one container or multiple containers. We still have Docker or another container runtime, so we still need that. Just to recap, Docker, as we've heard before, is working on one node. Kubernetes works on multiple nodes and enables us to start containers and make them connect to each other over multiple worker nodes. And on the worker nodes, we also have 2 components called the kubelet, which is the management component for containers. And we have the kube proxy, which is responsible for establishing network connectivity among containers. So So that's pretty much just Kubernetes, an overview. Control plane, worker plane. Control plane is responsible for controlling the internal state of the cluster, and the worker nodes are actually there to run containers at the end of the day. Okay, so that's a very, very 101 intro into containers and into Kubernetes. Now, let me give you some best practices on how to get started, because cloud native is a very, very wide field of technology, of community, of things to know and to learn and to get started. There's a lot going on there. And it's definitely not easy, but it's definitely also worth it. Maybe I can give you some hints on how to get going faster. I definitely would recommend that if you are starting as a developer or an admin, if you want to keep foot in this whole cloud native ecosystem, definitely start with some easy explanations. Not joking here. YouTube, Udemy, online video courses, go to meetups, to webinars like this, just to get some easy and somewhat understandable content before you actually dive deep into these tech blogs. I can highly recommend the platform Medium, as they provide like great articles to certain topics. There are great tutorials on GitHub, entry-level tutorials, but also like the really, really deep dive technical tutorials available on GitHub. So GitHub is still like the kind of most important technical platform for all this stuff, since also most of the projects are being hosted on GitHub. Once you're actually familiar with what's going on, and if you have some idea of how containers work, how Kubernetes works, what else is out there in this whole ecosystem, what these project names might mean, how the CNCF works, etc. If it's of advantage to you, you could pursue a certification. The Linux Foundation or the CNCF provides like a gazillion different certifications, but the most famous one is probably the CKA, which is the Certified Kubernetes Administrator. I'd personally recommend to start with the KCNA, which is the Kubernetes and Cloud Native Associate Certification, which is a multiple choice exam. And you're somewhat required to actually learn not only about Kubernetes, but actually about the whole ecosystem, to understand how it's connected. Not that technical deep dive, but this will give you a great overview of the whole ecosystem, of the most important projects, of where to find documentation, etc. CKAD is the Kubernetes focused developer certification. Yes, as I said, from my personal point of view, and that's just really just personal opinion, the best way to get started in this whole field is just to start with some introduction on YouTube, Udemy, some online video courses, which is not as dry as just reading documentation, but still gets you already some experience and some knowledge. Once you're able to grasp what actually the content, the documentation, the blogs will be about, you should focus on tech blogs, since they're usually more in detail, more concise than these lengthy videos. Again, I can highly recommend Medium, and some GitHub tutorials are out there. There is actually like this one repository which is called Kubernetes the Hard Way by Kelsey Hightower, who is like the creator of Kubernetes, where you're getting this very in detail, step-by-step explanation on how to set up Kubernetes from scratch. Should you like or need it, do some certifications. The entry-level one, the associate one, is the KCNA, Kubernetes and Cloud Native Associate. Then there is the developer certification, CKAD, and then there is the admin certifications, the Kubernetes administrator, and the security specialist, which is the kind of the most highly, the hardest and the most highly regarded one. Also, personal suggestion: start with containers and Kubernetes, and once you're profound and if you're good with Kubernetes, then try to proceed with adjacent topics like security, observability, whatever. Because if you barely know the ins and outs of containers and Kubernetes and already start with adjacent topics, this might be a little bit overwhelming and hard to understand what's actually going on there, since most of these technologies are already built on top of Kubernetes, so you need to be familiar with that at first, and then you can progress to other topics and other domains. As an organization, and I'm working in consulting industry for 2 years now, the first thing we always tell our customers is that you need to start with your mindset. Might sound cheesy, but it's definitely the truth. You can't just deploy a Kubernetes infrastructure and expect it to run perfectly and to actually being used the way it should be by your staff. The first thing you need to change is the mindset and how to approach problems and solutions and technology. And then you can actually make use of this Kubernetes and cloud native stuff. The thing is, we always try to make people understand that you're stepping away from this very static infrastructure. You're going to more ephemeral infrastructure. Things are spawned up and shut down on a higher frequency rate. You don't click anything anymore. It's not like this old Windows Active Directory stuff anymore. You automate whatever you can. You do everything as code. You will want to use the cloud, most likely, especially as an organization, because things are usually way easier in the cloud than to implement this stuff on premise with existing your own existing data center hardware. You definitely, as an organization, need to implement the culture of learning. So what I mentioned before is actually the approach you need to take as a person, but you need to foster a culture of learning as an organization to make people or to enable people to actually learn all this new cloud native stuff. If you don't have a culture of learning and you just expect people to know or to figure it out themselves, this will not work. Promise you that. If you want to get started, and that's also something we recommend quite often, start by consuming services first. You don't want to build your Kubernetes infrastructure as code platform on premise as a first step, but you first want to get going with infrastructure as a service, platform or software as a service. And once you're familiar with the paradigms on how to consume such things, how to use them, you can then start to build it on your own if you need it at all. If it's not required by the law or I don't know, by some regulatory states or something like that, or policies, I would definitely not recommend doing cloud native on premise, since it's usually just more effort and more pain than it's worth it. And of course, as a consultant, but also as a cloud native user, if you're actually new to all these terms and to these domains as a company, try to get started with some external help. Try to kickstart your first experience, if nothing else, but at least to avoid common mistakes. And there is just so much you need to know and you need to learn that it will save you a lot of money if you just hire an external consultant to help you get going for the first few weeks or months, instead of learning it all on yourself and failing forward. If you're talking about technically, again, if you want to start from scratch technically, get a consultant, have them work out a game plan to avoid costly mistakes, especially architectural mistakes. You don't want to work with the wrong platform, with the wrong providers, with the wrong products or projects, because you just didn't know better. Hire somebody that knows the ecosystem, that can get you at least work out a game plan. If you implement it on your own, fine. If you have the financial means to also have somebody implement it for you, probably even better, but at least get some help. Technically speaking, if you're then somewhat familiar with this cloud native ecosystem, the first thing that you will actually want to do is you want to containerize your applications. So before you actually start to build Kubernetes clusters, all this automation on top, consider security or observability or whatever, the first thing you actually want to do is to actually see if you're able to containerize your applications in the first place. The next thing you will want to do is to establish some kind of automation culture, infrastructure as code, pipelines, CI, CD. This is a technical thing, but that's also kind of a mindset thing. So you also need people to switch their approach from manually deploying to certain infrastructure to actually doing it automated in terms of pipelines, in terms of deployment systems, whatever. So you want to foster automation at this stage. And once you're actually running your first applications on a cloud native platform, as early as possible, start with observabilities and some KPIs and metrics. The later you start, the harder it will get, and the later you try to enforce an observability standard on your applications, the more tedious it will get. And it also is it's not just convenient, it's also sometimes business critical that you know what's going on in your infrastructure with your application. So use observability as soon as possible. This will pay back 1,000 times. And again, just try to crawl, walk, run according to the plan you figured out in the first place, and not just skip the first 2 steps and try to run away because everything is so easy and there's a lot of documentation online. You definitely will fail. You need to crawl first, you need to walk second, and then you can run. You need to know your basics and you need to know what you're doing. Otherwise, you will run into big trouble, guaranteed. The technologies work, but you still need to be able to use them as a person, as an organization. All right, and with that, we're pretty much done. I put some links there together for you for further reading. What I talked about on the previous slide was called actually the CNCF trail map. That's actually a nice representation of where they describe on how you get going as an organization from a technical point of view. So start with containerization, orchestration, security, observability, etc. The maturity model is a more management and organizational focused document that will describe how you actually develop your organization through certain maturity levels on certain domains. Definitely worth reading. I also included the certification curriculum, which will tell you what you need to know for the certain certifications I mentioned, the application developer, KCNA, CK, etc. I also linked the annual report and the annual survey. The survey is more tech focused, the report is more ecosystem focused. If you plan to attend events, there is also a link to official CNCF events like the KCDs. Again, just reach out to your local communities, which is also usually even more fun to attend small events and smaller meetup groups. I added the landscape, which will give you an overview of what's actually out there in terms of projects and members and companies. There is a publicly open Slack also by the CNCF, which you can join, since all the communication in the CNCF will happen either on Slack or on GitHub. It is totally transparent, so you will even see the communication channels of the highest technical and organizational charters in the CNCF. And I also included a link to Fippy and Friends, since there is also like a child-friendly domain of how to convey Kubernetes knowledge to children based on small little goofers and animals, which is called Fippy and Friends, which is actually quite cute. All right, that's it. Thanks for having me. If you have any questions,